Covalent bonds. So atoms are most stable when their valence shell is full. So remember our octet rule that atoms like to have 8 electrons in that valence shell or that outer shell. And chemical bonds help atoms achieve a full valence shell and increase the stability of the atoms. A chemical bond, then, is the force that holds together the elements in a compound. And remember, a compound is 2 or more elements. So a compound is 2 or more elements, and they're held together by chemical bonds. Now, sharing electrons can fill the valence shell. So if we share electrons, we get covalent bonds. So the attraction of 2 atoms for a shared pair of electrons is a covalent bond. So our example over here, we have 2 hydrogen atoms. Okay, we know it's hydrogen because it has 1 proton in each one. Now each one of these has 1 electron, so they're not really happy. So if they share electrons, though, now they have 2 electrons each, which, even though that's not 8, these are smaller atoms, so they are happy with just 2, because that first shell, remember this first shell of electrons can only have 2 electrons anyway. So basically what we end up with here is H2. So you have 2 hydrogen atoms that have a covalent bond. So molecules. So a molecule is composed of 2 or more atoms held together by covalent bonds. Now these could be atoms of the same element or atoms of different elements. It doesn't really matter. Molecules have a neutral charge overall, so there's no charge on these. So that means they have equal numbers of protons and electrons. Our example here with our water, H2O, which is this molecule over here. If you count them up, you have 8 protons in your oxygen. You have 1 proton in each hydrogen, so you have a total of 10 protons in a water molecule. And if we count up our electrons, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So 10 protons, 10 electrons, they cancel out, so there's no charge. Now, a compound composed of molecules is a molecular compound. Remember, a compound is made of 2 or more elements. Okay, so if I have 2 or more elements that are held together by covalent bonds, produce molecules, then I have a molecular compound. And polar molecules. So atoms in a water molecule do not share electrons equally. Okay, some elements have a stronger pull for electrons than others. In this case, oxygen pulls electrons more strongly than the hydrogens do. So the electrons are more strongly attracted to the oxygen atom. So this results in a slight negative charge near the oxygen atom, just this one, and a slight positive charge near the 2 hydrogen atoms. Okay. So what this results in is a polar molecule because there's a positive end and a negative end to the molecule. This is really common in any compound, really, that has oxygen-hydrogen bonds, because oxygen will always pull electrons away from a hydrogen. Some examples here, other than water, you have different sugars which have OH groups on them. A lot of times we just call these hydroxide groups or hydroxyl groups. Alcohols also have hydroxide groups on them. So these OH bonds are pretty common in those molecules, which creates polar molecules. Now, you could also have nonpolar molecules. A lot of these are hydrocarbons, which are made entirely of carbon and hydrogen. Like, for example, this is methane. It is a hydrocarbon. It is a nonpolar molecule because, for various reasons, but there's no charge on it, so there's no positive or negative end to it. So this is a nonpolar molecule.